vanadium redox flow is firstly cheaper than lithium, and it can store huge amounts of energy safely. And I'll explain to you why it's more safer than lithium. And then it's also more applicable. It's better to use, for instance, vanadium for grid storage than which is then vanadium is then more suitable for that, where instead of with lithium, it's more about power being made available immediately, like in motor cars. That's where lithium is very applicable. Now, vanadium is much heavier than lithium, so the density of energy is not as high as it is with lithium, and that's why lithium works with cars, and that's why it's so expensive as well. A vanadium battery would not work in a car because the density of energy is not as much as it is with lithium, and it's not as light as lithium. But then the conversely as well, lithium has got some propensity to combust and cause problems because of something that's called dendrites growing between the anode and the cathode. That causes a short, and that then starts a fire, which is, lithium is very volatile in nature. Anybody that's been to school will remember that. As soon as you expose lithium to oxygen, it reacts. And that's what happens then, which makes lithium a bit more unsafe. Then also different chemistries are used in a lithium-ion battery. You have not only lithium, you've got cobalt there as well, you've got graphite and nickel, a lot of nickel. And then with vanadium redox flow, you only have vanadium because vanadium has got 4 oxidative states. So we're using only one element. There's nothing else interfering with it, so that makes it safe. Then secondly, also, you can recover a lot of it. You can recover 95% in the electrolyte at the end of the lifetime of the battery, whilst with lithium, it's much more difficult to recover the lithium out of those batteries that's been used. And then, of course, I think that's maybe where your question was going to is to what extent would it be important to store huge amounts of energy? And if we want to achieve the targets that the world, some governments have set ourselves to be electrified, I think Germany said electrified by 2030, 50% electrified, then you need to firstly store a lot of energy, because the problem is that if you're not using conventional fuels, gas and things like that, and you're using renewables, you're dependent on the cycles of nature. And the sun doesn't shine always when you want it to shine, and also the wind doesn't blow always when you want it to blow. So that energy then needs to be stored until it's ready to be used by us humans, and then it will go from where it has been in the sun to the battery, from the battery to us. And that's where the vanadium makes a real magnificent difference. Yes, so the timetable is that we will be finishing the DFS most likely by the end of September. That will then show us what the numbers are with the highest level of certainty that we could expect to have. That will then give us the confidence, and our off-takers and our principal financiers, the confidence that the project has got a certain risk level, has got a certain financial return, and then we can then in that time after September, we'd probably start concluding off-take agreements, which is very important, because one needs to have an off-take agreement, especially with something like vanadium, where your off-taker has got the balance sheet to warrant your off-take, and then make sure also that they sell it then profitably to the market. Then tied to that is the principal funding, which relies on the off-take, and we would then aim to get that in place. That's from banks, typically from banks, but also a number of other options that's available presently, especially with relation to ESG, because we have a green element to the company, which is the vanadium redox flow element. And then once that is done and we've got the money, which is $200 million, hopefully that stays around the same number, then we would do construction of the mine. That would take about 18 months, including commissioning. And then once that has happened, then we would be in production. So assuming that it takes a short time, and I'm not suggesting it will take that short, but let's assume it takes about 6 months to get the principal funding going, then we could be in production by the end of 2024.